Hi, colleagues. Can you hear me? It's our first time streaming. I'm not sure whether everyone can hear me well. Oh, hi, Yusuf.
Hi. Thank you for inviting me to this great event.
Thank you for sparing your time. Sorry for such delay. We're doing it first time, so it will be a little bit technical delays.
Yeah, no problem.
Let me, if you allow 1 minute more, I will double announce to our community so more
Sure.
people could join. Thanks. Yeah, we're ready. I think it will be recorded. For some reason, thank you, Amina. Hi. Some reason there is Woman Tech Maker Ashgabat logo on the background. Not sure why. Well, probably it's not a big problem. And there was a message from another community member.
Yeah.
Any questions?
I can get started when you are ready.
Yep. So let's start. Sorry for delay. Probably.
Yeah, no problem.
It's Google Developers Nursultan community's first live stream event, and there are 450 people in our community. People usually show up late, so most of them will watch in recording later. Also, there's a co-host Diana. She's muted. It's our and let me introduce Mr. Yusuf Sarigoz. He's co-founder and AI engineer at AI Labs in Turkey and a Google developer expert in machine learning, Tensorflow. Yusuf, how would you like to make this event? Whether it will be keynote speech and we have some questions?
Maybe I can first start with the questions your committee members posted before the event. I can start answering them. Then we can go on with some hands-on demonstration of Tensorflow in the cloud. And if committee members can post their questions during the event in the comments, I can answer them as well.
Mm-hmm.
So cool. you can just interrupt me and ask the questions posted by your committee members.
All right. So everyone is free to ask questions in the chat, and if needed, I will voice them. Thank you. Let's do like this.
So great. You shared the questions with me, and I noted them. I will try to answer them one by one.
All right.
First question was, what language do you use at work and why? As natural in machine learning, actually, I'm a usual user of Python programming language. it has a great community, both in machine learning and also for full stack tasks like web programming, graphical user interface, and system programming. Whatever tools or whatever development you are making, Python community and Python packages provide you with great tools to make your development easier. Of course, at my startup, we are working with ML on the edge, which means that we are working with embedded systems. So to boost the performance on these embedded boards, we are also using C++ very frequently to get benefit from every byte of this embedded system has. So the other question was pipeline and credit boosting trees. Yeah, this was the question. To be honest, I don't work with predictive analysis. Usually, I'm working on the computer vision and natural language processing tasks. But I don't have enough experience in predictive analysis that uses these the decision trees. So it's not a kind of question that I can answer properly. But for gradient boosting, XGBoost is a great library to to make any kind of predictive analysis without much effort. On Kaggle, many challenges can be solved easily and efficiently with XGBoost. So I can strongly recommend giving a try to XGBoost. The other was Keras or Tensorflow. Actually, Keras is now deeply integrated to Tensorflow. So it's almost impossible to make a choice like I'm using Keras, but I don't use Tensorflow, or I use Tensorflow, but I don't use Keras. It's not such a choice. Keras is officially recommended by Tensorflow as a default model building tool in Tensorflow. All the tensor objects and Keras layers are interchangeably used together to build models both easily and also in a personalizable, customizable way. That means you can easily implement custom operations, custom layers by using low-level or tensor objects in TensorFlow, and you can use them in Keras models as of version 2.0. The other question was, what do you think is the future of neural networks? Actually, AI or ML is going to tiny machines, I think. Like we are, for example, At the TensorFlow World Conference held in early November or late October, I don't remember exactly, but something like that. Google and TensorFlow announced the TensorFlow Lite for microcontrollers. With that great tool, you can use your TensorFlow models of the size with the size of like 100 200 kilobytes. You can convert them to TensorFlow Lite for microcontrollers format, and then you can take them to some Arduino boards having ARM Cortex M4 series of microprocessors. So you can build intelligent, tiny things. Especially, it's very useful for the Industry 4.0. So I think that the future of neural networks is doing AI ML on the edge, devices with limited memories, with limited compute capabilities. This is because every day the privacy concerns are on the increase, especially in the West, European Union and Turkey, and also in the United States. The privacy issues, the privacy concerns are on the increase. So people don't want their data to be transmitted to some servers remotely. They want their data to be kept just in their devices. So this makes it compulsory to make AI ML on the device. The next question was Google Collaboratory or Hadoop. Actually, these are two very different things. Google Collaboratory is a hosted Jupyter notebook-like environment where you can test your ideas easily and without the trouble to install anything on your computer. All you need is just a modern browser, and you with that browser you can go to Google Collaboratory and instantly you can use any Python packages. Actually, it's a virtual machine provided by Google.
Is it has, like Jupyter notebooks? Do they provide like runtime?
Its interface is very small to Jupyter notebook. Actually, after answering these questions, we can go to Google Collaboratory and make some coding together. So it will better exemplify what I'm saying now. On the other hand, Hadoop is a distributed file system for big data. It has a file format called Hadoop distributed file system. So you can start with only one server and go bigger up to 1,000 servers when your file storage needs are becomes bigger, I think. So it's two different things. You don't need to make a choice among them. What kind of laptop or computer do you have at work? The last question. Actually, I have a moderate laptop at work because the majority of our work is done in the cloud. So I strongly recommend this. You don't need to invest a great amount of money to start with some machine learning or data science things. Google Corpora already provides you some free usage limits. You can easily develop your ideas or test your ideas on Google Corpora. And when you need to go to production, several cloud providers offer great resources to both train and also make inference with your ML models. Google Cloud, Amazon Web Services, Microsoft Azure, all these cloud providers have great cloud tools. You can easily use them when you need to go to production. My laptop has like 32 GB of RAM, 512 of SSD. It's a regular development laptop, actually. It has 1080 NVIDIA GTX 1080 Ti. Again, it's a regular GPU, easily found any gaming laptop.
Cool.
So, yeah, these were the questions you shared with me. If
Thank you very much for.
Yeah, thank you too. If committee members can post their questions during the event, I'll try to answer them as well.
Probably that's all questions which we prepared in advance. Just one more question from me before we go into details. Question about flexibility of this vision AI, because in Nur-Sultan, probably in Kazakhstan in general, vision AI is not widespread yet, and we are not familiar with this platform. How flexible is it in terms of, you mentioned computer vision. If I have a business task to sort of identify image recognition of Coca-Cola bottles, say, and as I understand, using Vision AI, I can train my neural network on the cloud. But can I? The question is, can I then extract this model and use it locally without Vision AI platform? Because probably for somebody it might be expensive every time to send requests there.
Yeah. First, I want to clarify the names of the tools. The Vision AI, I think you are referring to, is called AutoML Vision. This is a automatic machine learning tool specifically aimed at training computer vision models for image classification and also object detection models. You provide your data set. That means a set of images divided into or placed into subfolders based on their categories. And you also provide a CSV file, comma separated values CSV file, and this CSV file has two columns. On the first column, you have file names, and on the second column, you have category names. And with some evolutionary techniques and reinforcement learning techniques, these are collectively called neural architecture search. Basically, what it does is it searches for a proper neural architecture that can efficiently learn the dataset you provided. After the training, you have some options. You can either serve it as a web API, or you can download the models and use them anywhere you want. You can either embed them in the mobile application, or better, you can integrate it with Firebase to automatic continuous model deployment. Firebase ML Kit has a tool for this.
Can I use it in Amazon Web Services storage EC2, which is just a storage?
Yeah, sure. You can download the binary model files,
awesome.
and you can write a script to make inference with these models, and you can deploy it to AWS EC2 instance.
Great, awesome.
Yeah.
And just one more question from me. Sorry about a lot of questions. Is there somehow our community could obtain some, I don't know, trial thing? Is there some on trial period for this AutoML engine? Like sort of we have this quick lab credits, which is awesome to try. Is it can it be applied to AutoML as well?
No, Quick Labs actually is only for learning purposes.
Yeah.
You cannot make any actual training with the Quick Labs credits. Rather, it aims at teaching you how to use these tools. After, if you are new to cloud tools, you can first go to Quick Labs and take the labs there. After having some experience with these cloud tools, then you can start actually using cloud tools with your own cloud account. At the beginning, Google Cloud Platform has a free tier up to $300. This is valid for 1 year, and you can use it for any GCP cloud tool. I strongly recommend making use of these free trial. Actually,
Okay.
it will be enough for implementing your idea, bringing your idea to the real life, and when you go to production and make some money with your idea, then you can pay your cloud credits easily with the money you are making that idea. To begin with, this $300, I think, will be more than enough.
Thank you. One more question we just received from Amina Kurmanbek from Nur Sultan.
Yeah.
I'm reading it out. Thank you very much for answering my questions. What do you do daily in your startup AI labs? Question: if I want to open my startup in Kazakhstan,
I think the question is about our products. So we are developing variable hardware that has some ML models on them. The first use case is for the blind. We are building a mini camera connected to some ML processors. The camera streams the video camera footage to the ML processor, and ML processor can process the stream with the 4 AI ML models and provides audible notifications to the blind user. This is one of our projects. The other project is a mobile document scanner with automatic page flip detection. This means you place your phone on a phone holder. This phone holder enables you to hands-free. You place your book under the phone's camera, and when you start flipping the pages of the book, the mobile application we are developing can recognize these page flips automatically and captures high resolution images. It makes developing, desqueuing, or binarization on these images to make the image quality higher for the OCR in the next step. And after making OCR, optical character recognition, in these images, the application can read aloud the recognized text for the blind, but also for library researchers, academicians, university students, anyone in need of fast and high quality scanning needs. And finally, we are building contextual chatbots with NLP techniques. These can be used by municipalities, companies, anyone who wants to provide a smarter communication channel with their target customers or users. These are our projects currently we are currently working on?
It sounds as that portfolio of these projects brings a lot of value to users. Thank you for sharing this. And last question from Amina. If she says, if I want to open my startup in Kazakhstan in AI field, in what area should I start? Probably the broad question probably is about the context. What is probably I think it's about how in what popular industry it will be.
So actually, NLP is one of the hottest fields in machine learning. Since 2018, the biggest changes and most exciting developments in machine learning, we can see them in natural language processing. Computer vision has already solved the majority of its problems, but NLP still has some problems remained unsolved. So if you have some experience in NLP, definitely it can be a great field to begin with. Secondly, again, the field we are working in, ML on device. If you have some experience with embedded programming, if you have some experience as a maker, you can also go on with this ML on the edge trend. Is again a hot topic and will be huge in the near future.
About this embedded programming, and you mentioned maker. Did I heard it right? Is it a big problem to launch on a mobile device, on a, for instance, Android phone, an application using computer vision to detect some objects? How difficult is this, bearing if we have a business requirements that it should have supporting several types of mobile phones?
Yeah, actually, mobile phones are great tools to make your models bring to your target users. A lot of developments, a lot of great tools you can find for mobile application development. Tensorflow Lite again is a great tool to turn your ML model efficiently usable on Android mobile applications. It has some optimization tools. For example, you can compress a model of 30 MB of size. You can compress it to like 3 or 4 megabytes.
Wow, awesome.
So it has great optimization tools. Both the size, you can both compress the model size, but also you can make it faster on mobile devices. And for iOS development for iPhones, Apple has its own mobile ML toolkit called Core ML. Again, yeah, it's called Core ML. So again, it provides great optimization for models to be used in mobile applications, especially and these mobile phones have great cameras, so you can easily build very useful models and build a mobile application with them. You have the possibility to replicate very expensive dedicated machines. You can replicate them as a simple mobile application with these ML on mobile tools.
Mm-hmm. Thank you. I have actually on this a lot of questions. Probably we'll have a separate discussion. I propose. Should we proceed to the keynote speech, which you prepared? Would you like me to remain the screen as it is, or should I do like this? Please, or
you can add my screen to the stream.
Yeah, I've edited it, but do you want audience to see our faces, you and me? Now I shared 3 screens.
It doesn't matter actually.
Okay,
you can go with the choice you like.
Now everybody can see your screen.
Yeah, okay, great. So we talk about AutoML vision. Actually, it's a simple tool. Actually, it's not a ML tool. It's more like a tool for full stack developers. So I will not go on with the demonstration of this AutoML vision tool. It has a Quick Labs laboratory also. You can go and test this tool with the Quick Labs lab. It's very simple. You just prepare some data set, upload it to Google Cloud Storage, and train your model. It's just simple. But today I want to demonstrate another tool. It's called AI platform. AI platform is a serverless cloud tool to train your ML models and also make inference your trained models. So you can implement your model architecture with Tensorflow. You can write the code with Python and just upload it to AI platform. All the virtual machine creation, GPU optimization, other hardware related, runtime related tasks are solid done by AI platform itself. So all you need to do is just write the model architecture tool. We will review one such example, and then we can go to Google Collaboratory to actually deploy this code to AI platform and train it in the cloud.
Okay, cool.
So the first Python code is task.py. This is the entry point of our code. we will, as you can see, we are making imports from Tensorflow. As I said before, Keras is now a submodule of Tensorflow, and it's the officially recommended way of building models with Tensorflow. So we on the line 12 we implement a function called VGG block. This function accepts some parameters. One is block input. The second parameter is the second argument is number of the filters to be placed in convolutional layers, and the last argument is number of layers. This block will have this number of layers. For this, we will make a loop on line 13. And we are creating 2D convolutional layers with that number of filters according to the argument the function accepts. Then we apply some batch normalization here. And finally, we apply ReLU activation to the output of these layers, and then return the output for further use in the remaining of the model. Then on line 22, we are implementing another function called VGG8. This is a simple model architecture, very similar to VGG16 or VGG19. That is a model architecture developed by Oxford Computer Vision Laboratory, I think. So our model, this function also accepts an argument called args. These are this variable, this argument holds all the arguments we are passing from command line. So the code will be easily customizable via command line without making any changes in the code file, in the source code. So we first have a input layer. Then we add VGG blocks using the function above. Then we apply max pooling layers on top of the VGG block. Again, another VGG block, but this time the number of filters is 32 instead of 16 in the first block. And in each block we have 2 layers, but the number of filters is increasing. To the twice as the block as before. on line 32, again, we apply a batch normalization layer. Then the layer is dropout layer. Dropout layer is used for preventing overfitting. Overfitting simply means that your model memorized your training set. We are splitting the data set into two as training set and validation set. We train our models on the training set, but we are testing our model on validation set. This enables us to see if our model memorized our training set or if it learned some generalizable features, patterns from our data set, so that they can correctly predict unseen data unseen during the training period.
Understood.
Then we apply a flatten layer. Flatten layer helps us convert 2D data to 1D data, because we applied some convolutional layers on the image, which is two-dimensional. But we want to apply a dense, fully connected layer. Fully connected layer multiply every neuron with each one of the neurons of the previous layer. So they need to be 1D vectors, actually, vectors of rank 1. Finally, on line 38, we create our output layer. And this output layer has num classes neurons. We take this number from the args argument passed to our function. This equal to the number of categories, number of classes in our dataset. So if you have, for example, 6 categories in your dataset, this last layer will have 6 neurons, and we apply softmax activation to this layer. Softmax activation basically returns a probability distribution. That means all the summation of these 6 neurons will equal to 1. So it will be a probability distribution. The highest value, the neuron with the highest value among these 6 neurons will be the prediction of our models. So, for example, you are trying to classify some animals, and the neuron representing the category of cats is like 0, 0.89, and others are very small numbers like 0.001 or 0.001. They are very, very small numbers, but the summation of all these neuron values will be equal to 1, and we will select the highest value and treat it as the prediction of our model.
Awesome. It's, thank you for this.
So online
comment.
Sorry, I couldn't get the.
Thank you. You literally commented each line. So
yeah.
Thank you.
So online 44, we are defining our main function. This will be the function that runs when we call this Python code from command line. So we will define an argument parser to accept all the command line arguments to pass to the VGG8 function above. First, we get input size. This will be the dimensionality of our images that we will feed into our models. For example, if this is 200, our images will be cropped to 200x 200 pixels and then fed into our model. The other argument is non-features. This is the number of neurons in the dense fully connected layer just before the output layer. And num classes, this is the number of categories in our dataset. Train dir and validation dir. These are the path to directories holding our images for our dataset. Then batch size. This denotes the number of images we are feeding to our model at each step during the training period, the training phase. And epochs. One epoch is the actually this controls our model can see how many times controls how many times our model sees the images in our dataset. For example, if we give this argument a number like 5, our model will see all the images in our dataset 5 times during the training phase. And job dish is the next argument. This argument will control where to save our trained model after the training task is complete. On line 56, we create our model by calling the function above. and we pass the arguments we get from the command line. On line 58, we compile our model to make it ready for the training. On line 59, we create our train dataset and validation dataset by calling a function from utils. We will review it also. And finally, we feed these datasets to a model by calling the fit method of our model object. After the training is complete, on line 66, we save our model into disk by calling the method save of our model object again. And on line 72, we call the function main to get all these code up and running. So I'm going back and I want to review this. Utils. This code provides our utilities to pre-process images in our dataset. Why do we need to implement such pre-processing functions? Because the image data generator provided by Keras is not compatible with the Google Cloud Storage. Image data generators in Keras cannot read images from Google Cloud Storage. In AI platform, we will upload our dataset to Google Cloud Storage, and AI platform will read those images from our Google Cloud storage bucket. To be able to do so, we need to implement our pre-processing functions in a way compatible to or capable of reading from Google Cloud Storage. TF.data API can read from Google Cloud Storage, so we will use it here. On line 8, we are implementing a function to randomly flip images. We will provide some data augmentation with these random functions. They will enable our model to see very different images at each step. They will be randomly flipped, cropped, or their brightness will be randomly changed. So our model will be more stable to unseen data when you need to go production.
Awesome. This is because probably often is the case with stability of this, especially in computer vision. It's a nice. component.
Because these models can easily overfit to our trained dataset. So it's very important to make some data augmentation during the training phase.
Yusuf, want to pause for a second and to decide with you. Usually we do this with the length of the live streams, 1 hour, or how many time do we have more? Maybe what was your original plan for this keynote speech?
I think, yeah, I just wanted to make the demo with AI platform. Maybe we can do that at a later time. You can set a date for this.
Maybe if it's if demo is not take long time, maybe we do it now. What do you think? If it's like 3-5 minutes?
I think it will take some more time. I think, yeah, around 1 hour.
I see. Yeah, I think 2 hours is probably a lot for our people. I'm not sure whether they will stay here.
So you can arrange another event to continue with the demo.
Okay, cool. Let's do like this. When it could be convenient for you? What date?
Or we should maybe next weekend.
Cool. Next weekend.
Same again. Next Sunday.
Next Sunday, same time.
Yeah.
Cool. I will arrange this via the application.
Yeah. We can follow up with the email and arrange the event next Sunday.
I will follow up right now. I'm colleagues, our audience. Do you have more questions? We have had a lot of questions to Yusuf today. We probably finished all questions which you sent. If there will be more questions, please feel free to write them now, or you could write afterwards.
Or we can answer them next at the next
Sunday.
event.
Great. Okay, let's do like this. And there's a question. Amina saying, I appreciate a lot. Thank you very much for spending your time. I got GitHub.
Thank you too
Amina said.
For inviting me and to anyone attending to this online event.
Thank you very much. It was first our encounter in GDG Nur-Sultan with this platform and technology and AI platform. And thank you for thoroughful commenting of each line. It was really interesting the way you think and how it works. It's a lot to think about. And to those people who didn't attend live, they will watch the recordings. And see you on the next session. Looking forward to live demo.
See you. Thank you. Have a nice day.
You too. Thank you. Bye. You take care, Yusuf. Thank you.
Bye.